So hello and good evening from Europe and good morning from the USA to wherever you are in the world. Thanks for joining us for episode 5 of our live webinar series, The History and Future of Electrophysiology. Thanks also if you are viewing the recording. My name is Stephen Brown from Acutus Medical and I will be your host for this session and our ongoing series of webinars. Each episode will be recorded and posted online. The links to this and previous episodes can be found via the registration site. This week we will spend 40 to 45 minutes exploring ACQMAP's unique diagnostic capabilities in practical use. Today, I'm privileged to introduce a pre-recorded session prepared by Dr. Tamas Szili-Torok from the Erasmus Medical Center in Rotterdam. During and following the recording, Tamas is present to respond to your questions. To support these discussions, I'm pleased also to welcome Dr. Graydon Beattie, our Chief Technical Officer, and Dr. Derek Chow, Senior Director of Science and Technology at Acutus Medical. So please submit your questions via the chat button. For those of you less familiar with Zoom meeting format, you'll find the chat button at the bottom of your screen near the center. If you do have questions, activate this feature and type it in. Please post to everyone rather than just to Tamas, Graydon or Derek, as this will allow the entire faculty to enjoy them. Okay, so without further ado, let us commence the video. ACQMAP, the future of technology in practice.
First of all, I would like to introduce myself. I'm Tamas Szili-Torok, an electrophysiologist in Rotterdam, Erasmus Medical Center. And today I will cover our experience with the ACQMAP technology. And the title is, of course, made it on a funny way, but I really think it's true. We are talking right now about the future of electrophysiology in the practice. And I must say also that I'm happy that I can participate in this series of talks. These are my disclosures. Today I will cover the following topics. I know that some of you already saw the first 4 presentations of this series, but maybe not everybody. So I will start with a short introduction of this technology. Then I will talk about our approach, how we integrate it with remote magnetic navigation in Erasmus Medical Center in Rotterdam. And through 3 nice case examples, one persistent atrial fibrillation, a patient with frequent but short duration atrial tachycardias, and an atrial tachycardia where we had to perform biatrial map, I would like to show you what this technology can mean for us. And at the end of my presentation, I also would like to share with you our first clinical data. Before I start, I would like to give you an overview how I see currently the development of electrophysiology. You know that we are dealing with many arrhythmias, and in order to have a chance for better treatment of this wide spectrum of arrhythmias, we need to improve in some fields. The possible improvements are written here with red. So in the last decades, we invested in a lot of developing new technologies and better understanding of energy sources and energy delivery. A lot was done in imaging, image integration in mapping systems. We know that mapping and navigation through robotics is also a field which is rapidly evolving. And when we talk about atrial fibrillation, for instance, of ventricular tachycardias, we had big steps in understanding the mechanism and better understanding the substrate. Despite the fact that our knowledge probably in all of these 4 fields are incomplete, the electrophysiology improved enormously in the last years. But when you look at those 4 points, there are only a few industrial partners who can provide support in all those 4 fields. In other words, most of our partners are focusing on either one or the other one. That's why in the practice, in the last few years, frequently I had a feeling when I treat a patient that, oh, I should have done another technology. I should have chosen another technology for that particular patient. Acutus and the ACQMAP technology has the potential to improve in all of these 4 fields. It will come with contact force sensing technology very soon. The catheters will be volted, which I find very important, and my own research in the last few years proved that it gives important benefits. The imaging is echo-based, and with this echo-based imaging, we can provide a true anatomical mapping online. This is also unique. There is a chance for stereotaxis integration, which is very important in Erasmus Medical Center. And in terms of substrate analysis and substrate mapping, the dipole density charge maps and the super maps will give us great opportunity. Using the ACQMAP catheter, you already see a very beautiful catheter, which is you can call it almost like an industrial art, but it's much more than that. This is an over-the-wire catheter, as you can see on this figure. And the catheter has 48 ultrasound transducers and also 48 engineered electrodes. The shaft is 10 French, and it, in an open way, it has a 25 millimeter diameter. The ultrasound transducers are used for the anatomy reconstruction, while the electrodes are using unipolar, these are unipolar electrodes, and they are measuring charge and voltage, in other words. And this allows us for a unique map which displays dipole density charge on a real-time anatomy. This is a very fast technology, and mapping is also very quick. Therefore, it can be used very easily for remapping procedures without significant lengthening of the procedures. Here on this movie, you see how the anatomy acquisition is performed. So you see these ultrasound pulses. These are M-mode ultrasounds. They reach and reflect of the chamber wall. The individual points are accumulated to form a surface with a mesh density comparable to the segmented CT, actually. And the post-processing of the surface data completes the reconstruction, as you can see on this movie. So the electrical map is based on measuring charge density, and it provides propagation history. There are different views provided, voltage view, and row dipole view, and the propagation history. I find it very important that when you look at the spatial and the temporal resolution is extremely high. So it can provide almost 120,000 ultrasound measurements of acquisitions per minute. It has 150,000 intracardiac unipolar voltages per second. And each map is divided into 4,000 triangles with charge data that gives us also resolution of 1 millimeter. At the end of the mapping, you see on the right lower side of the slide, the system will provide us its findings with color codes. There are focal sources, rotational sources, and irregular activities detected during atrial fibrillation. And these are color-coded into purple, green, and yellow, helping the physician to perform the ablation. The new generation system and in the future systems, we can talk about a high versatility as well. This is a system which can provide us 3 different ways of mapping. One of them, and the first one, is the standard contact map. I don't think I think it's beyond the scope of this talk to talk about the principles of contact mapping. It is much more interesting to talk about 2 specific mappings of Acutus, of ACQMAP, the super map, and the single position map. During the super map, as you can see in the middle part of the slides, the operator is moving in the chamber with a basket catheter, and the system indicates for us if the mapping of the certain part good enough. And then the operator can move further, and then at the end of the mapping, it provides us a color-coded propagation map. This is very fast, and this kind of mapping is very useful to map repetitive rhythms because the algorithm that is based on is specifically designed for repetitive rhythms. If you have a rhythm which is not repetitive, but for instance, like very irregular, then we can use an other type of map. That's the kind of single position map of static map, when we find an optimal position of the catheter in the middle of the atrium, and then it takes a beat-to-beat mapping of a spontaneous, intermittent, simple or even complex arrhythmias, even when they are unstable. Based on this technology, on this slide, I would like to share with you how we actually select the patients for the different procedures, and what is the current stage of the usefulness of this technology. We do approximately 1-2 procedures per week with an Acutus technology. And what you can see on this slide, our lab is mapped with standard mapping systems. All of the mapping systems are at the center that are capable to do sequential contact mapping. And then we have ACQMAP. So when you look at with the blue, I indicated the type of procedures that can be done with both systems. With red, I indicated the type of procedure done with an ACQMAP currently, and with the green, and that you can see in the lower right part of this slide, I show you procedures that we exclusively do with the ACQMAP currently. So when we talk about paroxysmal atrial fibrillation, stable flutters, and other kind of procedures, you can freely choose between standard sequential contact mapping and ACQMAP. On the other hand, when you have a patient with short runs of atrial tachycardias or any kind of unstable atrial tachycardia lines, or redo atrial fibrillation, then the veins are isolated and you want to do some more, exclusively use the ACQMAP system. The only procedure type where currently we cannot use Acutus is the VTs. And in some grown-up congenital heart disease patients, and it's something to do with the manipulation with this catheter in extremely complex curved anatomies. The unique feature that we have in Erasmus MC is the integration with remote magnetic navigation. You see that in this slide I show you an integrated module on the remote magnetic navigation. We use the stereotaxis system, and this is a typical screen that we see during these integrated procedures. In the upper left corner, you see the displayed electrograms, the ablation catheter and the coronary sinus catheter. Here on the right side, the upper part, you see the X-ray image, and you can clearly see that the ACQMAP catheter, the basket is closed, but it's in the left atrium. Here on the left lower panel, you see the ACQMAP catheter. This is made by the ultrasounds and transmitted into the stereotaxis system. And from the moment when it's transmitted to that system, we can work further with a remote magnetic navigation. The major advantage of this is that a single operator using that screen can operate all of the features. And the other important advantage, yellow arrow, and this is the indication of the direction of the magnetic field. You can very freely manipulate the catheter that I show now on the right upper X-ray image. This is the ablation catheter with 3 magnets throughout the chambers. And it gives a very superior maneuverability as compared to the manual ablations. In the next image, I would like to show you that ACQMAP system, for instance, now I mapped with the catheter the veins, as you can see on the right lower panel. Just with one click, we can transmit again this modified image to the stereotaxis system, and we can further work with an improved and processed anatomy, as you can see now in the left lower panel indicated with my mouse. And on this last slide, I just would like to show you how the ablation is done with this integrated system. Again, if you focus panel, you see this orange coloring, and this is the place where I deliver radio frequency energy. You see on the electrograms that the patient has an ongoing atrial fibrillation, and the ACQMAP showed us the substrate in those places where I performed the ablation. And during ablation, you see that within a few seconds, right now, the atrial fibrillation terminates and the patient converted into sinus rhythm. In the next part in my talk, I would like to show you 3 important cases to demonstrate the capabilities of the system. The first case is a patient who is a 79-year-old male, and he was referred with long-standing persistent atrial fibrillation to Erasmus Medical Center. The first episode of his atrial fibrillation was recorded in 2015, and since 2017, he's known with long-standing persistent atrial fibrillation. Last time, month before this procedure, he also underwent an unsuccessful electrical cardioversion. He does not tolerate amiodarone. He actually has a decreased left ventricular ejection fraction with left bundle branch block, but not an extremely dilated left atrium. The most important point here is that although he's relatively aged, his quality of life is enormously influenced by his atrial fibrillation. He was very committed to do the ablation. When he came to the lab, you see the 12-lead ECG showing atrial fibrillation, and also the intracardiac electrograms. In both, you see that he has relatively low voltage waves, and this is quite consistent with long-standing atrial fibrillation in this aged population. And mostly, we must admit, this is associated, especially when the patient has low ejection fraction and some other comorbidities, low success rate. When I have these patients on my outpatient clinic, I always explain to them that the chance of having a successful ablation is around 50%. We started this procedure with a standard pulmonary vein isolation. After the pulmonary vein isolation, we perform the ACQMAP. And this is the first recording of the static mapping. And this is the dipole density charge map, and using a single position atrial fibrillation map. And you see that these colors are representing the propagation during this atrial arrhythmia. And I don't think any electrophysiologist can make anything out of it. But when you focus now on the image, you see that the system shows us this color-coded findings, with the purple being focal, green rotational, and being irregular activities. When we have this, we start eliminating these sources using the magnetic navigation, and during the ablation, the following happened. So we ablated these patients on the parts that I showed you just before, and during the ablation, you see that the rhythm at that point becomes regular, and the patient develops a regular atrial tachycardia around 270 milliseconds. Now we perform the ablations on the spots that I showed to you, and this is the 12-lead ECG of this converted atrial flutter, and you can also see the intracardiac electrograms. Here comes the beautiful feature of the super map, because now we are dealing with a regular map. So we have a regular tachycardia, so we have more time to move around the catheter in the left atrium, and this super map has a specifically designed algorithm to pick up these regular rhythms. Shows consistently here a focal activity. This is the very first activation in the left atrium during this tachycardia, and from this it activates the rest of the left atrium repetitively. And this was just near the right superior pulmonary vein. I would call it, it's the junction between the right superior pulmonary vein, as you can see on this upper left image, and the roof. And just a single RF application here, as you can see on these electrograms, terminated this atrial flutter. This patient is doing. Now the second patient I would like to show you is a patient who is only 33 years old, female. She has no any comorbidities except that she has an ASD, which is unrepaired, so it was not yet closed. And she is known with palpitations more than 10 years. Her ASD doesn't cause hemodynamic problems, so it was actually not planned to be closed. But the major problem is that her palpitations last sometimes not more than 2-3 seconds. And in her whole life, the longest episode was 2 minutes. And the only way how we could see them is 7 days water. Otherwise, we cannot see those heart rhythm problems in this patient. So when you have only sequential mapping, actually nobody has a chance to ablate these tachycardias because it's extremely difficult to map them. We brought this patient to the EP lab and we applied ACQMAP. And the advantage of the ACQMAP that you always have a chance to do the static map, which means that even if she has only 2-3 seconds of problems, of heart rhythm problems, you can have a single beat map. But when we are lucky and we can have a few seconds or a minute long tachycardia, then we can apply the super map. And this happened. This patient had around 10-15 seconds of atrial tachycardias, and we were able to do a super map. And this was very interesting, the finding, because first we mapped the right on the left lower panel, and what you can see, again, a focal tachycardia from the septum, a relatively low septum. This is just under her ASD. Because of the ASD, it was very easy to enter with a catheter into the left atrium, and you see our left atrium map. And the left atrial map is corresponding exactly to the same spot that we saw from the right side. It is very adjacent to the right atrial map. So based on this, we decided that we will do biatrial ablation for this patient. And on this image, you see that we performed ablations from the right atrium. This is the left upper part of this slide, and from the left atrium as well on this right lower panel. And this made the patient non-inducible, and in the first, she has so far no longer than 5 months follow-up, but during this 5 months follow-up, she didn't have any recurrences so far, and she feels like somebody who is reborn. Now, the third patient I would like to present to you is a 64-year-old male. It's also a growing population. This patient represents a growing population. His first episode of atrial fibrillation was in 2000, and in 2010, he underwent pulmonary vein isolation. In the next 4 years, he had any recurrences. In 2014, he developed atrial flutter. It proved to be an cavo-tricuspid isthmus-dependent flutter, and that was ablated. And interestingly enough, 9 years after his pulmonary vein isolation, he developed first recurrences of atrial fibrillation last year. It went very fast to persistent atrial fibrillation, and he even had as well an unsuccessful electrical cardioversion. His left ventricular ejection fraction and left atrium is normal, and we admitted the patients for a redo ablation. During the redo ablation, of course, like everybody else, we check first the pulmonary veins, and all pulmonary veins were isolated, which is not a surprise when you look at that he was asymptomatic for 9 years. We performed an ACQMAP, and based on this ACQMAP, you already know this. This is made during atrial fibrillation. We again detected irregular activities, some focal sources, and some rotational activities. As you can see here on these colors. On the posterior wall here, you see the rotation. in the left panel, and in the right side, you see the irregular activities and the focal sources. During ablating it, similarly to the first patient, the atrial fibrillation converted into atrial flutter with a cycle length of 290 milliseconds. Again, the system is very flexible. We started with a static map, and then it was very easy because now we ended up with a flutter without actually spending a lot of time on a sequential remap, contact map. We just did a super map, and you see here the super map. Now it is very interesting to see that this map, you can, the best to see on the right lower panel is showing a perimitral flutter. I will play it again. So you see that the activation goes around the mitral valve and arrives back. In this patient, you could see in the previous map that because of the substrate that was detected in the anterior wall, we performed an anterior line, and this anterior line was drawn with an ablation catheter between the right pulmonary vein, the right superior pulmonary vein, and the mitral valve. I must say it's quite challenging to do this line manually, but with a stereotaxis system and with the magnetic navigation and the magnetically guided catheters, it is a quite easy line. And when we have a substrate here in the anterior wall, we always perform this line. When you look at this image, it is obvious that the line is not perfect. At the point where that we indicated with a yellow dot, there is a gap on the line, and that can be the reason, and that can be the proarrhythmic substrate for this flutter. So we tried to ablate that, and it didn't succeed. So finally, this perimitral flutter, we ablated with a posterior line, and in this next slide, you see that the flutter goes on, and during ablation, the patient terminates into sinus rhythm or converts into sinus rhythm. We performed a post-conversion supermap in sinus rhythm in order to see the continuity of the line. And this is very interesting because exactly at the same spot, again, you can see on this right of left lower panel, I try to show with my mouse, there is again a gap on this line that we couldn't ablate during atrial flutter. We terminated the flutter with a posterior line, and after this I spent another half an hour trying to complete this line, and in that particular case, unfortunately, it remained unsuccessful. So I'm very curious to see what will be the follow-up of the patient. He will definitely not develop perimitral flutter because we completed the mitral isthmus ablation with a posterior line, but it can develop either a septal tachycardia or another microarray entry using that gap. So as I announced, at the end of my presentation, I would like to show you our first clinical results with this integrated approach. Here you see again the three different conduction patterns, the focal, the rotational, and the irregular activation patterns. In order to localize the substrates during atrial fibrillation, we used the scheme from the publication of the Bordeaux group, and we divided the atrium into these standard parts. So what you can see here, and that shows how important is the magnetic navigation. We compared our data between the patients done with remote magnetic navigation and with manual ablation. It is very interesting to see that when you compare the first map with the final map, you see actually a similar decreasing of the substrate, of the presence of the substrate in the posterior wall. So it actually does not matter in the posterior wall whether we use remote magnetic navigation or manual ablation. On the other hand, when you look at the anterior wall, and I just mentioned it during the last patient, that how challenging it can be to perform lines on the anterior wall. The difference between the initial map and the final map is quite huge when you use remote magnetic navigation. In other words, using those catheters and the integrated module, we are able to eliminate large number of this substrate, while it is less successful with the manual ablation. So that's why I'm so enthusiastic about this integration. And then as last, based on the previously mentioned cases and our first clinical results, I would like to draw the following conclusions. Using ACQMAP technology has a significant added value for diagnostic and enhanced anatomy. It has definitely an added value for fast mapping. It is probably the only technology that can approach on a very effective way short runs of atrial tachycardias, and those can be easily and effectively mapped. It also provides a universal solution for patients with different types of arrhythmias. For instance, when we start the ablation in atrial fibrillation, and during the ablation procedure, the patient converts into atrial tachycardias, it provides the possibility of fast remapping. And the ACQMAP in combination with remote magnetic navigation provides additional advantages due to the superior navigation capabilities. Thanks for your attention.
Tamas, thank you very much on behalf of all of us for an excellent overview of ACQMAP in practical use. I'll invite you, Graydon and Derek, to discuss the outcomes and implications of the presentation and to look at any questions that have come in via the chat area.
Tamas, can you comment a little bit on the procedure times, say the robotic navigation compared to manual?
That particular question I cannot answer right now because scientifically we haven't analyzed the data yet, but and I also have to be careful because now we are biased, so we do most of the procedures with a stereotaxis system, and the manual ablation we only do actually if we have planning problem and we have too many patients planned in stereotaxis, for instance, for acute VTs. But in the first set of patients, I had a feeling that this facilitates the procedures, so actually we can achieve much shorter procedure times. It's also something to do with the development of this system itself, I mean the magnetic navigation system, because recently in the last years, at least in Europe, because it's C-labeled but is not yet FDA approved, a contact indicator module is available, and this this allows us to have a much better and much faster ablation. Actually, I see in the chat function one question maybe for you guys. When can you come with VT? I explained in my slide that there is no VT, and maybe you guys can.
Sure, I'd
tell
like to
why
pass that.
and when.
I'd like to pass that over to Derek.
Yeah, it's a great question. We're very, very interested in taking this technology into the ventricles. We've started some work in preclinical models to understand not only the capabilities of the mapping technology itself, but also just the logistics of access, maneuverability, et cetera. So far things are looking really good. From a mapping perspective, I think that our capabilities will translate. And then there are additional things that we'd like to look at in the future, including activation, epi versus endo and transmyocardial, things like that will be advancements that we'll be pursuing in the future as well.
And maybe you can comment on possibility in the future to measure even functions during ablations. I mean, because you have the ultrasound, so actually, theoretically, it's possible to do that.
Right, that's right. The fact that our ultrasound is omnidirectional, we can sense we can use it in effect to track the wall motion all around the chamber, which allows us to do something that most to try and track motion in an ungated way. And so we've been able to, for example, in preclinical scenarios, look at the motion of the ventricle during a PVC, and to the extent that you would then be able to use this technology to look at both the electrical as well as the mechanical behaviors. We might be able to understand and utilize an understanding of the relationship between the electrical and the mechanical.
And then going back to the procedure time question from Graydon, I see that Wim is also signed in this webinar, and today he was in our lab and we did a case. And this was also a very interesting case because that particular case could have been planned with the sequential mapping, because the guy is in left atrial tachycardia since months, but I planned it with Acutus, and it turned out that it was a very bright decision actually, because Murphy's law, so the guy is in months in a left atrial tachycardia, is quite stable. It's like 350, 360 milliseconds. When you introduce the coronary sinus catheter, you see a clear left-sided tachycardia, and we put everything in the left atrium, including the catheters, and then at that moment, it turns into another tachy, which is like 200 milliseconds. And nobody knows, is it clinical? Is it just made by the mechanical irritation? But I couldn't get any more the original tachycardia. So it was very, I think it was very fortunate that I had the ACQMAP because we could map very fast the first tachycardia. We ablated. Also, we needed to do this anterior line that I just explained in my presentation. And it was pretty tough. And during this process, we actually ended up with 3 different tachycardias. At the very end, we got the clinical tachycardia. And that was when we ablated that one, the patient returned to sinus rhythm. And I don't know the exact numbers, but I think we did at least 6, 7 remaps during this procedure. So even if you have a very fast hand with a very fast multi-electrode mapping system, it takes 10, 15 minutes per map, also with editing and then additional ablation time. So it increases, this kind of patients increasing the procedure time enormously. And it was not a short procedure on this way, but we could finish it, I think, within 2.5, 3 hours successfully.
If I can follow on a little bit on that question, then what would you say was the average time for manipulating and hovering the ACQMAP catheter around for obtaining the SuperMAP by comparison to the sequential map?
It's much faster. So you need time, you need some stability of the tachycardia for those. Although I think you guys know much better than me, but even if the tachycardia terminates and you could not complete the SuperMAP, in some parts it can be already used and analyzed and gives better information, just the static map. And by the way, in these patients, we always did a static map at the beginning, and then we started with the SuperMAP, and together with the 2 maps. So we did 2 maps per tachycardia. It didn't take more than, let's say, 5-6 minutes, together with the analysis. The ablation was a bit tougher. Mapping was quite easy.
If you had happened to have been in that case with a conventional contact mapping system, even with a high density catheter, would you have been able to complete it, or can you describe what you would likely have encountered in that situation?
I can describe it one word: irritation. And I think it's very difficult now because I really don't want to lose credibility. So I'm a fan of all of the other systems, and this is an Acutus webinar, but it is true. And every electrophysiologist all around the world knows that it's extremely irritating to do the 5th, 6th remap if necessary. And in this case, it's just relaxed.
Another.
Having said this, for instance, if you have just one tachycardia, one stable tachycardia, which is not very complex, probably there is probably you cannot win time, because although the mapping is fast, this is a complex device, and you have to prepare the device, you have to change the sheath currently, hopefully not in the future. You have to go into the left atrium. So with one tachycardia, you don't necessarily win any time. The time winning comes after the 2nd, 3rd, or the 4th in this case.
Mm-hmm. Is there any indication before you start the case whether you're going to see one or several?
No, actually, in this case, it was just sixth sense, but in many cases, you see already clinically multiple types, mm-hmm. And then we definitely, as I showed in one of my slides, we plan the patient with Acutus.
Right.
And again, I must emphasize that in the second case, that's also a growing population when you have a non-sustained or even just a few PACs per patient, and can be very difficult to get those. And in the past, there was one system, the Insight array, which was able to do that, but the efficiency and the accuracy of that system is just simply not comparable to this.
In fact, that's part of the design requirements for this system, based on intimate knowledge of the performance of the previous methodology. That's an important point to make, that this is designed to address the limitations that you've just mentioned. This is another question.
From Vince, that I just read it, that what other integration features could we add to the stereotaxis Acutus integration that would further improve the system for me or for the colleagues? It is pretty advanced integration. One of the things is, of course, that when you remap, you still have to do it manually. And when you do the SuperMAP, you move the catheter manually. I don't think it will change because one of the most important features of the stereotaxis system is the extreme safety. And probably designing, they have a robotic arm, and designing an integrated module when you move the catheter with that robotic arm, I don't think it would be extremely attractive. On the other hand, using that robotic arm just to open the catheter and closing the catheter, I mean the basket open, I show and close, just to allow better manipulation of the catheter around the chamber. Yeah, I would consider this, because then you save a lot of comfort for the operator, and then you win some more time.
Gentlemen, fascinating conversation, but I'm going to have to start drawing things to the close. If you have a quick summary from any of you, then we'll have to finish. So any further last comments?
My last comments, you saw it on my conclusion slides. I think if centers are dealing with those patient population I just showed, I think they have to consider this mapping system, because now I don't really see any other competitors moving into that direction.
Tamas, Derek, Graydon, thank you so much for your input. It's much appreciated by us all. So at this point, any unanswered questions that we have, we obviously will follow up. And should you wish to revisit this webinar, it will shortly be available online, where you can already find previous episodes via the registration page. So please make yourself available for episode 6 next week at the same time. ACQMAP, Visualizing Substrate. Here I will be delighted to introduce again Derek and Graydon, and they'll explore how global chamber mapping gives us a unique view of atrial substrate and how to explore it. So until episode 6 next Thursday, May the 21st, thank you so much for joining us, and goodbye.